This is a tutorial on multiplying and dividing rational numbers, part 1. And actually with part 1, the only thing we're going to focus on is the multiplying part of rational numbers. And remember that a rational number is any number that can be written as a ratio, see it in here, which means it's just a fraction. So we're going to be multiplying and dividing fractions. And for now, we'll just stick with the multiplying. So let's say I have 1/3 times 2/5. If I want to think about what this problem means, a context might help me to understand my answer a little better. And with me, I like to think about food. You might have guessed that. So I'm going to say that my mom made a cake when I was younger, and I have I have 4 brothers and 2 sisters. So if she made a cake, a lot of it was probably gone by the time I got home. Well, let's say that what I end up getting to eat is 1/3 of 2/5 of the cake. Remember that with multiplication, the word that they're oftentimes going to use for that is of. So like in elementary, when it was 2 times 3, notice the elementary multiplication symbol. When it was 2 times 3, we knew that it meant 2 groups of 3, 2 groups of 3. So now this is 1/3 of a group of 2/5. Clearly we're not doing elementary math anymore, but we can still represent it visually to help us understand it a little better. So I get 1/3 of 2/5 of the cake. So when I think about this, I'm starting by thinking about what the cake was originally cut into. And if I get 1/3 of 2/5, that tells me the cake was originally cut into fifths. So I'm going to go ahead and do that. I'm going to divide this cake into 5 equal sections, which means they will all be fifths. Notice that's what it says right here. Now, since there's only 2/5 of the cake left, I guess that means these 3/5 were eaten by my brothers, which is probably pretty accurate. But these 2/5 left are available for the rest of us to eat. So I'm going to go ahead and fill in the 2/5 that are left and make them a light pink. Maybe the girls get those pieces. But I have 2 sisters, so that means there's 3 of us girls. And perhaps we decided to share them, so I'm only going to get 1/3 of what's left. And you see here, there's only 2/5 of the cake left. So I'm going to get 1/3 of what's left. So I'm going to try to cut the cake that's left into thirds. And this is a good practical division skill right here, trying to cut it into thirds. Clearly, I was not the one allowed to cut the cake. All right, so that's pretty close. Pretty close into thirds. And I get 1 of those thirds. Now here's the trick. You have to pretend as if the whole cake was there and you were cutting the whole thing. So even though there's only this much of it left, I'm going to extend that line as if I had cut the entire cake that way. And you'll see why that is in a second. So here we go. There's the 2/5 that are left. Now I'm going to take my 1/3. So I think I will claim it in yellow. Here's my 1/3. Very good. That's my cake. Oops. Hope I didn't do that. That would be bad. So there's my 1/3 of the 2/5. So when you look at this diagram, the 2/5 are all that's left, and the 1/3 is the part that I get. So I'm going to outline my part of the cake, which is right here. Those are my pieces. And that's actually pretty important because I want to know how many pieces I get. And you can see right here that I get 2 pieces, which is great, but I don't know if I'm getting my fair share unless I know how many pieces everyone else got, and unless I know how many pieces there were to begin with. So that's where the rest of the fraction comes from. I get 2 pieces, but it's 2 pieces of the total. And if we look at our total here, it's split into 3 pieces this way, 5 pieces this way. So you can see that it's split into 15 pieces. And of those 15, I get 2. So I'm getting 2/15 of the whole cake. And that's why we had to cut the thirds all the way through. We wanted to see all the pieces that would have been cut if they were all the same size as mine. And there were 15 that would have been cut, and I get 2 of them. So my answer, my fraction that represents my cake, is 2/15. I guess I'll just rewrite that right here. So 1/3 of 2/5 is 2/15. And I bet you can see why multiplying is a lot easier than adding and subtracting. We're kind of staring our answer in the face right here just by looking at the original problem. It really is that easy. We have 1 times 2 is 2. 3 times 5 is 15. I get 2 of the 15 pieces. Now you're going to find problems to be a bit more difficult if they have negatives in them or if the numbers aren't so small and easy to work with. For example, if I'd gotten bigger numbers here, I would have to look to reduce my answer because if you don't reduce your answer, for right now you're going to get an angry face. But pretty soon, that angry face is going to go away and you're just going to get no credit. It will be a wrong answer if you don't reduce it. So we want to make sure we reduce our answers. Now let's see if we can try a bit more complicated fraction multiplication problem. So let's say that I have negative, I'll even throw in some negatives, negative 3/7, and I'm going to multiply that by 14/15. Okay, so this is about negative 1/2. This is about 1, and if you kind of estimate in your mind a negative 1/2 times 1, we're thinking it's probably going to be about negative 1/2. And it's a good idea to make those kind of predictions before you even begin the problem, because it's going to help you judge how reasonable your answer is. But we're going to do the math and get the exact answer. And we already know one way to do that is to literally take negative 3 times 14 and then take 7 times 15, multiply those, and get our answer. But what I hope you're noticing is that these numbers are a little bit bigger than our last example. And I'm pretty confident we're going to get a fairly big answer here, and then we will have to reduce it. So I want you to take a look at this setup right here. Notice here's our division, here's our fraction. Now if I have something like 4 divided by 4, we know that that gives an answer of 1. These 4's can be divided both by 4 one time. So when we see a numerator and a denominator that have a common factor, we can simplify them using that common factor. Well, if you look up here, 3 and 7 don't have a common factor, and neither do 14 and 15. But 3 is on top and 15 is on the bottom. And as long as 1 is on top, 1 is on bottom, it is a division problem. It does not matter that they're kind of diagonal because the 3 is still getting divided by the 15. So we can take the 3/15 and simplify it. And to do that, we ask ourselves, okay, self, what goes into 3 that also goes into 15? And hopefully our self is smart. So we can say that 3 goes into 3. And how many times does it go into it? Once. And self, how many times does 3 go into 15? And that would be 5 times. So look how much easier we already made that problem right now. We changed 3/15 into 1/5. And yeah, I see that negative right here, but I always like to deal with those at the end. I don't mess them in with my numbers right now. I just take care of it at the end. So I've simplified the 3/15, and if I could simplify anything else, now would be a great time to do it. So I'm going to look at my other two numbers here, 14 and 7, and you can see that 14 and 7 have a common factor of 7. So 7 goes into 14 twice, and 7 goes into itself once. So now I've simplified those. And if I write out what I have left, it looks like I have a negative 1 times 2 on top, and I have a positive 1 times a positive 5 on bottom. And here, that might help you see it a little better. Okay. So now that I've done all the simplifying I can, I'm going to try to express my answer. So I look at the top and I have negative 1 times 2, which is negative 2. And you see how now the negatives really aren't all that difficult, but over here, if we had tried to worry about them, they probably would have messed us up. So save them for the end and then just deal with them, okay? So now we have our numerator of negative 2, and our denominator is whatever 1 times 5 is, which is positive 5. And for our answer then, that means we have negative 2/5. And if you compare that back to our original prediction of negative 1/2, it's pretty darn close, because if you have a number line right here, here's 0, here's negative 1, here's positive 1. We know that negative 1/2 would be right here. And negative 2/5 is pretty close to negative 1/2, but it's a little bit bigger than negative 1/2. Probably right about there, negative 2/5. And if you don't believe me, you can split this into fifths, negative 1, negative 2, negative 3, negative 4. This would be negative 5/5. So here we have negative 2/5. It's a little bit bigger than negative 1/2. So that is a reasonable answer, and we can feel pretty confident that it indeed is the right answer. And it's reduced, so no angry face for us, which is a good thing. And that should cover what you need to know about how to multiply fractions. If you're interested, part 2 is about how to divide fractions, so come back